Hello, my name is Roman and I'm representing Team Metacrank on the lablab.ai semantic search hackathon. And the team of Metarank is actually a team of one, a team of me doing all the things together at once. And we're going to talk about recommendations here, because recommendation problem can be defined as a computing similarity between your item you're currently recommending for and a set of candidates. And the similarity can be based on feedback from other people, like from interactions, because customer behavior usually kind of the same across your domain. So it's called collaborative filtering. It's plenty of different implementations, but the main problem of collaborative filtering is that to build recommendations, you need to have visitor feedback. To get the visitor feedback, you need to have recommendations, like chicken and egg problem. So you can't just build it because you don't have the data, and that's because you can't build it. And here comes the content-based recommendations, because we don't know the feedback about the items we're recommending for, but we do know the content, that the title, descriptions, all this information about things you're currently recommending for. And the main assumption of content-based recommendations is that titles and your content is semantically similar when the items are actually similar. So we can't just take an embedding of items and compare it to the vector search of embeddings and call it content-based recommendations. To see how it works in real life, we built a semantic movie recommender. We took movie lens/TMDB dataset as a source of customer interactions and metadata. We trained a baseline model for the matrix factorization ALS for like collaborative filtering to see as a sanity check what usually is recommended if we had feedback, and used cohere.ai and sentence transformers to compute embeddings and Qdrant for the vector search. And here comes the demo. It's publicly available here, you can play with, and let's click on the popular movies here and choose something. What can we choose? We choose Alien 3, and for our Alien 3 movie, our matrix factorization baseline recommended some other movies about like creepy movies, which are quite diverse. But if we go for the content-based recommendations made with the cohere.ai embeddings, we'll see that all the movies are actually about aliens. These are part of franchise. This guy is definitely an alien. These are also obviously some aliens. And if we check out the recommendations made by the sentence transformers, we'll notice that these are kind of the same, but these are not actually about aliens, but mostly about escape from something. And this is about Ripley, but not that Ripley you're looking for. So you might assume that the quality of recommendations is quite different across different types of recommenders. Okay, so how it was made? We didn't wrote much code for this type of demo, so because we glued things together with Metarank, and Metarank is an open source project to do recommendations and ranking, but the problem of this project is that it never had support for semantic recommendations, it never had support for vector search, and as a part of this hackathon, we actually build this type of support. That's the pull request for semantic content recommendations with the cohere.ai support. That's also a pull request for the Qdrant made, yesterday, which is already merged. And that's it. We also have a Flask UI to glue things together just for this particular demo. And at the end, if you see how it looks like inside of Metarank, with this two pull requests merged, it's just a bit of a YAML, like semantic recommendations with a vector search of Qdrant, and that's actually it. We put, machine learning in the YAML. Is it like a machine learning? Okay, that's it. Thank you very much. See you soon. Everything is available on a GitHub. Bye.